The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
In order to move to that real-time operations model, you need really good visibility, and you need it without having to re-instrument everything. So that's a place where software technology can be really helpful. Firstly, you need big data. You need to be able to use the cloud, and utilities don't mostly today, although that's changing. You need all the data. You need to make sense of it in real time. You need to be able to look back over years and look at trends. You need to never throw it away, and that's not what utilities do today. You need that technology that we've already developed.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Today on the Clean Power Hour, zero carbon grid orchestration. We're going to find out what that is. My guest today is Astrid Atkinson. She is the founder and CEO of a startup called Camus Energy. Welcome to the show.
Thank you. It's a pleasure to be here.
Really nice to meet you, Astrid. Looking forward to learning more about Camus and what you're up to in the world. Give our listeners a little background on yourself. How did you get interested in the energy transition?
Yeah. Happy to. So my background is on the software technology side. I was at Google from about 2004 and was really fortunate to be part of the early team that was helping to develop the kind of large-scale cloud computing approach that helped to build Google to what it became. In particular, I led up a lot of Google's early work on building highly reliable systems at global scale. So you kind of think about the transition to the cloud as, going from putting software on like one computer to putting it on 10,000 and having them work as reliably or more reliably than the one did. There's a fair amount of software and kind of operational approach to getting those 10,000 or 100,000 things to work reliably together. That was my field of expertise. So that was kind of what I led up at Google. And as I was kind of working through that and thinking about applications of that type of technology kind of elsewhere in the world, I was also getting interested in climate change and the climate and energy transition. My son is 10 now, but it was really around the time that he was born that I started to think about climate and the future that he would be inheriting from us. And it was when I realized that he was going to be 37 in 2050. And that, if anyone was going to be addressing climate change and really trying to fix the problem before it became disastrous for all of us, it was my generation and not his. That was really what got me kind of set on the idea of transitioning my career into the climate and energy space. And so I spent a long time thinking about where my specialty, which is very reliable large-scale computing, would fit into the energy transition space. And that's how I got interested in the grid, which is what we work with at Camus.
And what is the problem that Camus is solving?
Yeah, so we're fundamentally, firstly, we're a software and systems company. So we provide software, we work with utilities. And more specifically, if you think about the role of the grid in the energy transition, it's a pretty fundamental part of the kind of two-part story about how we decarbonize our energy system. And broadly speaking, there's kind of the two steps of electrify everything and then decarbonize the grid. The grid's a really important part of that step too, and it's underinvested from a technology perspective. It's also not nearly able to manage the volume of energy that we'll need to move across it in order to get all of that energy electrified. And we don't have that long to build physical infrastructure. So we're fortunate to already have a pretty big physical network that connects all sources of generation to most sources of demand. But we need it to work really differently. We need it to be really smart. We need it to be really efficient. And we need it to be not sort of infinitely expensive in order to play that role. And so that's what we do from a software perspective, is work with the people who manage the grid, which is primarily utilities, to provide them with the data and management and orchestration capabilities to get, all of those sources of generation and sources of demand working well together, to be able to address that problem at a systemic level.
Well, that's interesting. I am a little cautious because I am a solar professional, and we often run into utilities as a barrier to the energy transition, not an accelerant. There are many people who want to simply disrupt the utilities and completely reinvent the grid, because it is a wonderful machine, but it's largely outdated, as you mentioned. It's not built to carry 3 times as much electricity, which is what we need it to do. It's not built to handle distributed energy resources like solar, wind, and battery storage. But more importantly, it often becomes a major source of friction, right, for interconnection and permitting and getting projects across the finish line and making them financeable and affordable and speeding the energy transition, which is our mission here at the Clean Power Hour. So what do you say to that? And how do you affect change with when you're serving the utilities? I get it that they're going to need better and smarter tools, and we need a smarter grid. But is that disruption or that progress, so to speak, really going to come from them buying a better software platform?
Well, so the grid plays a really critical role. It's true that utilities can be one of the bigger hurdles in getting clean energy projects off the ground, but the grid's also the major enabler for getting that energy to the places where it's used. The physical connectivity that we would need to be able to get, the output from all of those solar projects or wind projects or whatever to, my house or yours or your business or whatever. It's basically the grid. It's not perfect. It isn't what we need it to be. It isn't, nearly as smart or as large or as easy to connect to as it's going to need to be, but it is there, and that's a pretty good start. If we want those wires or we want those means of moving energy around, then at some point, you're either going to connect them to the network that exists or build a new one. There is absolutely, I think, a really important role for more localized energy and getting more energy being generated at the places where it's also being consumed. And I think it's more of an and than an or kind of answer, though. Mm-hmm. We need all of those things together or we're not going to solve this. Mm-hmm. To answer the other part of your question, though, about the role of the utility and the opportunity to innovate in the grid landscape as it is today, there's a couple of things that I think are really important. Firstly, the grid as it stands provides a universal access to energy, and that role is really important. If we think about the opportunity for getting local energy into consumers at my house or your house, maybe we have solar on our roofs. I think my house is a kind of an interesting example. I live in the Santa Cruz Mountains outside of the Bay Area. We're actually having pretty significant reliability challenges here at the edges of the network with climate change accelerating. And because I have resources and I work in the clean energy industry, I have solar panels. I have 9 kilowatts of solar panels on my garage roof. And this last winter, we had about 45 days of power outage, which is quite a lot. I had a battery project that was in progress, and it came online at the tail end of that long, difficult winter for myself and all of my neighbors. And it fixed the problem exactly and only for me. I went from, being in a situation where I and all my neighbors were busy cutting, chainsawing logs and running the wood stove and all of those kinds of things, to not losing power ever. That fixed the problem 100% for me and for my house. But it didn't fix it for my friends who live next door. It didn't fix it for my neighbors down the road. It didn't fix it for the old lady who lives a couple doors up on the highway.
But so when you say you solved the
really
problem
cold.
for yourself, you installed a 30 kilowatt hour battery, or what did you do?
I installed a 40 kilowatt hour battery.
Hmm.
Yes.
Yeah. Yeah, I mean, a
Um,
big battery does solve the problem, but boy, that's a big ticket.
well, certainly. And it was expensive. And my neighbors can't afford that. And like I said, it's a localized but not a systemic solution. The grid provides that systemic solution, and that general access to energy is part of the core charter of utilities. So bringing it back to the second part of the answer to your question, utilities take that responsibility really seriously. There's a lot of things that, they don't do well or could do better. But if you really want to connect to the kind of core mission that lies at the heart of pretty much any utility, talk to them about the universality of access to power and the role that that plays in human civilization and in the communities that they serve. They take that super seriously, and they are the custodians of that role, making sure that everybody gets access to power and that in theory, it is universal and fair. In practice, always, there's a lot of devils in the details, but that is a core mission that they hold. When they think about their job, they also think about the job of keeping the lights on. And up until pretty recently, I think that getting solar power onto the grid was kind of ancillary for them to that role in a very significant way, right? Like not part of the day-to-day challenge of keeping the lights on, restoring power after storms, those kinds of things. That's changing really rapidly. Now, as my house bears witness, the old connectivity model is not necessarily working as well as it used to. Smarter utilities are also looking to the future and kind of asking themselves, okay, how do we serve that 3x demand load? And the moment that being able to manage that load flexibility and getting those localized energy sources on the grid becomes core to the mission of keeping the lights on, you're now in the territory of core capabilities for utilities and the things that they really care about the most. I also have a background in operations. I understand that if you're an operator and your job is to get paged at 3 a.m. or to be sitting there in an operating center at 3 a.m., trying to keep power running or services running in the middle of adverse conditions, you're not always super excited about people showing up with new technologies to be like, hey, I built it. Could you put it on your grid? But when it helps you solve that problem, that changes things really quickly. So that's a big part of the work that we do, is to give utilities the tools that would help them to treat the additions to their grid as a core part of their reliability mission, and to be able to support them in that goal of being able to provide universal, low cost and fair and reliable access to power to their customers. Like I said, that's really just, it's core to how they think about their work and what they do.
So give us an example of how that works. How does software help utilities integrate DERs into their day-to-day mission?
Yeah, so I think one of the interesting areas for a lot of utilities is the addition of EVs to the grid. This is it's a little bit, it feels like a kind of an old hat item at this point, because we've been talking about EVs for so long. But we are finally at the point where it actually matters, where the rate of EV adoption is becoming noticeable. And while I think all of us were interested in figuring out, how do you get them onto the grid? How do you get them to be providing grid services? How do you help people to electrify and encourage them to buy EVs and all of those kinds of things? How do you get utilities excited about supporting them? It was kind of academic until very recently. There's a couple of utilities that we work with who have been trying to proactively understand what the role of EVs on the grid is really going to mean for them. And I think one thing that's super important to understand about load growth is that it isn't really easy to capture the impact of load growth in like overall percentages, right? Like if you look at the IEA reports, we're still at like 2% year over year, and that's not very much. US government reports, likewise, if you just look at overall load growth, still not very high. But if you actually talk to utilities about what they're seeing, it varies a lot by territory. Some of them are seeing a couple percent load growth. Some of them, one that I talked to recently is expecting 17% by 2028 year over year, which is huge. And then within their territories, pretty much all of them at this point have areas where there's a lot of load growth that's really a cause for concern, whether that's factories going in or data centers are a big driver of load growth. But they're also sort of looking at EVs and thinking, well, that's the one source of load that I can't really, that doesn't show up on an interconnection request. How is that going to impact my grid? And if you actually model that on a feeder by feeder, like a circuit by circuit or substation by substation basis, taking a baseline from the EVs that are actually out there today, that starts to produce a really vivid picture of what the future could look like. You start with the baseline of maybe 2 or 5% of vehicles that are out there today on the highest load substations. And then you play that forward at a 10 or 20% growth rate year over year.
Mm-hmm.
Doesn't matter much this year, doesn't matter much next year, but it's an exponential growth rate. And by about 2026, 27, 28, suddenly you're looking at building new substations. And that's really soon by utility, from a utility perspective.
I mean, can't we just
Firstly,
Can't we just
understanding,
look
like, where
into the
those
future
EVs
by looking at Northern Europe? Because they're much further along in the energy transition. They're electrifying HVAC with heat pumps, and they're buying way, way more EVs. We're only at 5% here in the U.S. It's a good watermark, but there are places in Northern Europe where they're at 80+% of EVs.
It's kind of academic to most American utilities, I think, when they look at that and they think like, oh, I don't know. I don't even know how many EVs are out there today. But one of the things that we help our utilities do is analyze their meter data patterns to understand where EV charging is happening right now.
Mm-hmm.
Once you have the base load and you play that forward, that becomes really personal in a hurry. This is not like, oh, in Europe, someone's building new substations for EV load. This is on my grid in 3 years. I'm going to need many more than I planned for, and that's going to be really expensive.
Mm-hmm.
And now that's the most important thing I'm doing in my job.
Mm-hmm. But so is your platform something that is going to, that if I'm a utility, today I don't have Camus, tomorrow I have Camus, and I go, oh, no big deal. The grid is completely changing. Loads are going through the roof because of electrification of HVAC and industry and transportation. Yeah, how does that work?
Yeah, so we have two parts to what we do. The first piece is data integration. So we work with the utility to integrate data across their operational landscape, but also from their customer devices and program enrolled devices. So most utilities today have a pretty good handle on what's happening on their grid to the sort of substation level. Separately, they have a pretty good view at the meter level, but it typically trails by 6 to 24 hours. Some have the ability to put that together, but not most. And very few have the ability to incorporate any information about what's happening at the meter or behind the meter into their core operational systems. So there's that big gap between the grid as a utility sees it from their operations center, which goes, like I said, to the substation, maybe the recloser, versus what's really happening out there on the edges of the grid. Being able to incorporate information, firstly, about what's really happening with those EV locations, whether that's by connecting directly to the EVs and getting information from them or modeling it, and we do a mix. Firstly, understanding all of that information in context and what that's going to mean is helping to fill a gap that most utilities have. Secondly, being able to connect that to what you want all of those resources to do, from large scale solar, front of meter storage, all those things, to customer EVs, customer batteries, those kinds of things. Basically kind of being the brains of the operation. What do you want all those resources to do in order to make most efficient use of the network that you have? Mm-hmm. That's the orchestration part. It's how could you use a substation battery to offset the peak load generated by EV charging? The utility can control the substation battery. They might be able to control the charging times of the EV directly or indirectly. Understanding, firstly, what's going to make a difference, and then being able to actually get those messages to those EVs, those batteries, et cetera. We do both parts. We do both the data and the understanding, and then also the control. And
so it's helping utilities plan for the future, but also in real time manage the assets that they have, leveraging virtual power plants, for example. I mean,
that's right.
Sunrun is a force now, right? They're installing a gigawatt of solar a year. And their attachment rate has gone through the roof because of NEM 3.0 in California. I mean, I would imagine you're working in the California market. How many markets are you working in, and are you able to work in?
So today we're doing some work in California, some in the kind of Rocky Mountain West region, and then some on the East Coast, so Pennsylvania and Vermont. Today we're US based, but it really is kind of all across the country, and it's a range from utilities that are really seeing a lot of solar and local resource adoption to ones that aren't yet seeing that, but really want to take a leadership role in what that's going to mean for their communities as that comes online.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. Okay. So if I'm a utility and I've got this established business model, I'm a regulated monopoly, and that's true whether you're an IOU or a public power utility. There's not that. From my experience, they're not all that different. They are different. There are subtle differences, and it's very strange how regional it is. Like in Wisconsin, the munis and co-ops are embracing solar energy. In Illinois, they're not at all. They're pushing back, and it's only in IOU territory that solar is happening. So, if I'm a utility though, and I look out at this landscape of tools, so to speak. Why am I incentivized to embrace the future, so to speak? Because, that's one of the real problems that renewable energy professionals see today, is that they're not that incentivized. They have this business model of, we want to build transmission and distribution on a cost plus model, and we don't really care about the energy transition. We care about uptime for the grid, and when we don't provide that, society says, look, you're in trouble, and then the utility goes, well, we're going to bankrupt. Sorry guys, we caused a bunch of fires, and the grid went down. But I guess back to my question, if I'm a utility, what is my primary motivation to talk to you at Camus, and what is your experience, I guess? Like, do you have some secret door opening sauce?
So I think that question about motivation is really the right one, because that's really what it gets down to, right? Like, you never are going to sell a technology solution or a system solution to a customer that doesn't feel like it's fundamentally important to them and solves a core problem to their business. There's sort of no point. But it varies a lot depending on utility. And I think that's some of what you're seeing, region by region and case by case. For some of the local co-ops and munis, they have energy contract structures that do allow them to make money from local energy resources. So a lot of co-ops and munis are bound to long-term power procurement contracts with large providers like generation and transmission providers that don't allow them to buy power outside of that contract. So if they're in a 40-year G&T all requirements contract, typically a co-op's not allowed to buy more than 5% of its power outside of that contract. Mm-hmm. And that includes rooftop solar. Mm-hmm. So their ability to, let's say, go build solar in their territory and then get, solar at 3 cents a kilowatt instead of 10 through their generation and transmission provider contract. The financial proposition may be attractive, but their ability to take advantage of it is really limited. So some of them have broken their contracts and they can do things differently. Some of them already have partial requirements contracts and have the option to vary that. The nonprofit co-op and municipal utilities do typically care about cost of energy because they serve smaller communities. When the cost of energy goes up, their customers' bills go up, and then people yell at them in Walmart, and they don't like that, or they get voted out at the city council, or they get voted out of the co-op board. The co-op board will eventually replace the CEO if rates go up too much. So they're pretty motivated to keep rates low. They also likewise don't really like to build more physical infrastructure because that also drives rates up, and that cuts into part of their core mission. They might be motivated to adopt clean energy or to transition to renewables for, mission reasons if their community is really pushing on it. But if it's cheaper, they'll 100% do it right away if they have the ability. The other thing is if they have energy contract structures where reducing their customer usage during certain peak windows reduces their energy bills. And for some of them, that can be a really big deal. It saves them millions of dollars a year. Then they actually get really interested in customer load management technologies. So they love demand response. They love VPPs if they can make or save money on them. So that for that sector, that's a pretty big buying motivation for some of them. And it's really just to kind of save money for their customers. For investor-owned utilities, that's not so much the case. Like for most of them, energy cost is a strict pass-through to their customers. It's not part of their profit model, and they do have a profit model. So they're looking to make money on behalf of their shareholders. And in that profit model, they're typically looking at that regulated rate of return on building more infrastructure. So if they build a new substation, typically, they make 8% on the cost of that. And that's part of how they make money, and that is definitely a goal for them. So in theory, they should be really excited about load growth because there's more infrastructure to be built, more profit to be made. But that's been largely theoretical until recently. For many, many years, every year, they were like, oh, in 5 years, there's going to be so much growth. And then there never was. It was maybe a year, maybe 1% of load growth year over year, or even a drop because people were, actually the biggest difference for most utilities was the transition to LED light bulbs. It made such a big difference in overall demand levels that it really ate into all of the load growth that would have driven up their profits from building more infrastructure for a very long time. That's changing, but it's only just starting to change. The smart ones are really excited about EVs because it means that they get to build infrastructure, they get to make money. A lot more of that business that used to go through gas stations is going to go through them. A lot of the profit ultimately for the fossil fuel industry should be something that the utilities get to share in, but that's been really academic up until now. But it's also kind of scary for them because that might mean instead of building a few line upgrades and a substation upgrade year over year, now they might be looking at building 20. That's really expensive. It's 10 times the work. It's 10 times the cost. Probably wasn't in the plan. And so there's a bit of an opportunity for them, but it's also really scary, and they don't really have the tools to think about how would you deal with growth that is that rapid, and manage the costs associated with it and all of those things. So when you engage with utilities who are thinking about that, they are very, very, very motivated to understand, like, where's that growth happening? How can I manage it? How can I manage the costs associated with it? Because I'm excited about building new infrastructure, but I can't literally build infrastructure quickly enough to account for all that load growth in the next 5 years if it's going to show up in the next 5 years. And so that's why working with someone like us becomes really important, because it's like, okay, if it's going to cost like, I don't know, $1 billion to upgrade all my substations over the next 7 to 10 years for EVs, that's something that my regulator is going to be really concerned about. I need to prove to them that I'm taking all of the steps to lower those costs, to make my grid as efficient as possible. Suddenly efficiency matters a lot, where it didn't really matter to them before because they weren't really concerned about keeping load down. Mm-hmm. So that's kind of the context that we work with utilities within. Mm-hmm. And it's really in that context of that transition to full electrification is where what we do suddenly starts to matter a lot.
Yeah. I appreciate this kind of soup to nuts approach you're seemingly taking. You're servicing co-ops and munis, G&T providers, investor-owned utilities. If I was to go to your website and read the white papers there, what am I going to learn? I guess what is the aha moment for me if I'm one of those three or all three of those, right? Like I'm looking for. We need a breakthrough, right? We don't need incremental change. We need radical change. And while, distributed generation is still a small part of the grid, eventually, by 2050, it's going to be a major part of the grid. And I'm just curious, like how you see the evolution of the grid happening, because, frankly, you are involved in that visioning process. You are ultimately going to become the grease or some of the grease for the skids of the evolution of the industry.
Yeah, I think this is a really exciting time to be working in the grid. It is a very profound change that we're discussing, and that's kind of intimidating. But on the other hand, for me personally, like I was really fortunate to be part of a fundamentally transformational change in the computing industry. We went from a model in which you were kind of fundamentally limited in what sorts of problems you could solve in the computing space by how much work a single computer could do, to one where the kinds of problems that you can solve are fundamentally unlimited. And that was the transition, originally that made things like Google search possible, being able to bring back the best sources of information about any particular thing from the vast billions of documents out there on the internet in under a second is actually pretty it's really difficult to do from a technology perspective. It was a fundamental transformation in computing, something that we really take for granted now. I got my phone here, and if I want to know how to if I want to know how to open the trunk of my rental car at 1 a.m. after my flight's gotten in late, and I can't figure out how to get my suitcase in the back, I can ask that question of my phone, and it will be able to give me a video that shows me where the trunk release is in under a second. People have forgotten, I think, what a big change that was in the computing space. Even 10 years ago, when my son was a baby, when I wanted to talk to my mom, I called her on the talking phone. And then 6 months later, when I wanted to talk to my mom, I picked up my phone and I could do a video call with her. I was actually on the team that helped to build that infrastructure. I worked on a lot of stuff at Google, but that was like such a big change. Suddenly we went from like, I'm talking on the phone on the receiver to this Star Trek world where I'm walking in the park with my baby talking into my like little portal. The computing power that made that possible was a breaking change in the industry. It fundamentally changed how we use that network, what the network consists of, how it's built, how its topology works, what people do with it. And we need that change for the grid as well. And the details of, how you transition a network to be fundamentally distributed to do 10 or 1,000 times the work, I think are all sort of kind of boringly small, but that's also kind of the good news, right? Like we've solved problems around how you get networks to do more work a couple times over, between the internet, between telephony. We can do it for the grid. One of the things that I'll point to is that in kind of managing that transition process, and I did a lot of work on the operations side as well as the kind of systems infrastructure side and making this possible for Google. Just the power of being able to see what's going on is pretty profound. Most utilities can't see what's happening, and that's part of the reason they're conservative about making changes to the grid. On the transmission side, visibility is pretty good. On the distribution side, it's terrible. Like I mentioned, most utilities have invested in smart meters. That gets them up to what happened yesterday, maybe 6 hours ago at best. But that's not the kind of visibility that you would need to get like a minute-to-minute dynamic grid where could actually take advantage of my batteries to maybe service my neighbors, or a substation battery to offset the charging for my Tesla, or the 20 Teslas. Actually, there's not 20 Teslas in my neighborhood, that's just mine, but you get the idea.
Sure.
In order to move to that real-time operations model, you need really good visibility, and you need it without having to re-instrument everything. So that's a place where software technology can be really helpful. Firstly, you need big data. You need to be able to use the cloud, and utilities don't mostly today, although that's changing.
Mhm.
You need all the data. You need to make sense of it in real time. You need to be able to look back over years and look at trends. You need to never throw it away, and that's not what utilities do today. You need that technology that we've already developed, and you need to be able to fill the gaps. So being able to bring like machine learning and artificial intelligence approaches to bridge the gap between the data that we have and the visibility that we need, it's actually pretty transformational. So if you're going to kind of point to anything as sort of an aha moment, like what really makes the difference, being able to use those technology approaches that we built for the Googles and the Facebooks and the Ubers to be able to see what's happening on the grid so that you can make sense of it, that's going to make a big difference. It's going to make a bigger difference than people expect.
So I think we should just wrap up with some one or two concrete examples of the difference that you're making, for utilities, and you can pick a market. Is it California or somewhere else where the light bulbs are going off for your customers?
Yeah, I mean, I think a really interesting market is in the Rocky Mountain West region, where there's kind of a interesting intersection between investment in renewables and interest in local and distributed generation, the strong streak of independence in the West, versus some of those tensions around energy cost, transition cost, load growth, those kinds of things. A lot of those communities are seeing load growth or are seeing opportunity kind of come into their territories in the form of new factories being built, charging stations for fleet charging and, cross-country travel, those kinds of things, data centers, and just their, customers adopting renewable energy and smart grid technologies and smart load technologies like heat pumps and stuff like that. So there's this nice intersection between like a lot of renewables on the one hand, a lot of load growth, and then a lot of new technology that we can use to manage that load. So, there are multiple utilities in that region that have very aggressive decarbonization goals, looking to decarbonize by 2030. Those are typically the nearest term goals in the country. I have a couple of current customers with targets in that range. One of our current customers has already transitioned more than 100% of their daytime energy to local solar, built within their territory, connected to their distribution grid. And they're starting to look at selling that to their neighbors, which I think is really cool. For them, that becomes an industry and a source of revenue, ultimately one that could potentially be really transformative for communities with a lot of sun and not a lot of other local resources. On the flip side of that, those utilities that are looking at supporting really dramatic load growth from development, factories, data centers, those kinds of things, they really need tools to manage that cost and manage that reliably. They're looking at putting in substation batteries in the future to manage that, but they're already managing VPPs of customer battery to help them manage energy costs today and keep the cost low for all of their customers. And so those abilities to manage costs at the system level and really like put one customer's EV and their battery to work for the benefit of everybody. That's happening today with those local and regional utilities in Colorado and Vermont. They're setting a great example for what that's going to look like for everybody. So I definitely encourage people to look at the examples of those regional utilities to see what could this look like at scale, because putting those VPPs to work to support the grid and to keep costs low for customers, that's not an imaginary technology. It's happening in Europe as well. That's stuff that's really already starting to be demonstrated in the field in a number of places. I also think Australia is a really good demonstration. For us, those regional utilities in Colorado and Vermont, and soon to be other places in the US are the places where we're having the most benefit today. But that model of what a next generation utility that's operating their grid in real time in a localized way, we're helping that happen today, and a lot of people are making that work today.
Well, we have to stop there. I want to thank you for this interview. Check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple and Spotify. Please tell your friends about the show. Reach out to me on LinkedIn. I love hearing from my listeners and connecting with new people. And you can also contact us through the website, cleanpowerhour.com. Astrid, how can our listeners find you?
Well, we're on the web at camus.energy, camus.energy. Or you can find us on LinkedIn, Twitter, kind of all the usual places. I guess it's not Twitter anymore. Whatever it is now.
Wonderful. Astrid Atkinson, CEO and founder of Camus Energy. Thank you so much.
Thank you so much. It was a pleasure.
I'm Tim Montague. Let's grow solar and storage. Hey, listeners. This is Tim. I want to give a shout out to all of you. I do this for you twice a week. Thank you for being here. Thank you for giving us your time. I really appreciate you and what you're all about. You are part and parcel of the energy transition, whether you're an energy professional today or an aspiring energy professional. So thank you. I want to let you know that the Clean Power Hour has launched a listener survey, and it would mean so much to me if you would go to cleanpowerhour.com, click on the About Us link right there on the main navigation. That takes you to the About page, and you'll see a big graphic, Listener Survey. Just click on that graphic, and it takes just a couple of minutes. If you fill out the survey, I will send you a lovely baseball cap with our logo on it. The other thing I want our listeners to know is that this podcast is made possible by corporate sponsors. We have Chin Power Systems, the leading three-phase string inverter manufacturer in North America. So check out CPS America. But we are very actively looking for additional support to make this show work. And you see here our media kit with all the sponsor benefits and statistics about the show. You know, we're dropping 2 episodes a week. We have now over 320,000 downloads on YouTube, and we're getting about 45,000 downloads per month. So this is a great way to bring your brand to our listeners, and our listeners are decision makers in clean energy. This includes project executives, engineers, finance, project management, and many other professionals who are making decisions about and developing, designing, installing, and making possible clean energy projects. So check out cleanpowerhour.com, both our listener survey on the About Us and our media kit, and become a sponsor today. Thank you so much. Let's grow solar and storage. The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chinpowersystems.com to find out more.